Hi, everyone. We'll continue speak for the nature. This is nature's physics, or my physics, because I'm the only one doing it, and so I represent nature. And since I'm the only one, I am the nature. So this is nature talking. Okay, so last time we discussed a little bit of the so-called redshift, namely the light from the further end or far end of the universe appear to be red, and some people call it redshift. And then from there, then they thought about the Doppler's effect, and then they think the mother of these red lights are like a whistle on the train. So they're moving far away from us, and of course constantly. Therefore, their conclusion is that our universe has been, or is, or will be expanding. But I'm telling you that's not the case. There are plenty of reasons. I mentioned one reason last time, namely I compared the morning sun and the evening sun, the sunrise and the sunset. They all appear red. So that's not redshift. Similarly, the same reason for the light we see or our instrument received from the far end of the universe. Those lights or those photons arrived onto our Earth. They have experienced a lot. They came a long way. They appear red is not because their body being stretched so that their wavelength became longer, or their frequency become shorter or less, and that's not the case. Nothing of them have changed. Only that the red lights or red photons are more of a capability of trying to penetrating the universe, or the darkness is a bit better than the other color of lights. It's not because they being stretched red. It's only because they were red to begin with, and they arrived into our instruments. And the purple ones, the blue ones, and the green and yellow, and the other ones, they couldn't get here. They sadly, sadly, oh, I'm laughing, but sadly, they died on their way here. They may want to be here, for whatever reason. However, there are abilities of penetrating the darkness of millions or even trillions of light years of darkness. They couldn't make it. They didn't make it. Only the red ones made it, or and some others, of course. The ones near the red, they made it, and so we saw the red. That's it. However, since the idea of expanding universe came about, so I will discuss a little bit of just what is expanding really. Expanding, of course, it concerns another concept, that is the length, distance. So, therefore, the measurements. What is measurements? Measurements is very human, really. As a nature, right? As God, measurements means little or no sense to nature. However, if we look at human measurements, the history of human measurements, when we first started, we start off with some standard ruler, and later we not later, but yeah, later we use some better materials, like a stainless steel or something, or maybe copper, steel probably not a best choice, or maybe gold bar or silver or something like that. Currently, right now, 1 meter is defined by speed of the light. Although the light speed isn't exactly 30,000 or whatever, but there are a whole bunch of fractions, but that's how the 1 meter is defined, 1 over whatever property number of a speed of light, or the length of a light travel 1 second. Then we come up a ruler. But from nature's perspective, looking at us, nature would say the distance or the length is how many number of atoms you could place in between. As I said earlier, from the very beginning, nature has nothing but integers. I mean, positive integers, natural numbers. Nature doesn't even have 0. So the use a more of a what should I say? A daily language. Distance is how much stuff in between. More stuff you could put in between the 2 points, and further apart they are. Less stuff, then that's closer they are. So, actually, in some sense, you might even say the stuff between them currently, how much stuff in between is how close they are. 2 things, if nothing between them, only vacuum, let's say, or better, not even electromagnetic fields, nothing at all, you might even consider they are actually touching. Their distance is 0. Although that's not what human would say, but by nature, it might exactly what the nature would say, because there's nothing in between. So the distance may be understood as, from a human perspective, how much stuff is in between. From nature's perspective, how much stuff there are. Let's just, for example, between my thumb, if there's 1 million air, or let's say hydrogen atoms, okay, the distance is 1 million. Or I should say, if between my 2 thumbs there could only fit 1 million hydrogen atoms, okay, the distance between my thumb is 1 million hydrogen atoms, whatever you call it, 1 meter, whatever, or 1 foot. Oh yeah, foot, right? Yeah, you see how human the measurement is. I think it's some king's foot, British king even. However, if my 2 thumbs were in some vacuum, there is only 1 hydrogen atom in between them. From nature's perspective, the distance between my 2 thumbs may very well be just 1 hydrogen atom. That's it. no matter how many it could be fit in between, but there are only one at this moment. So that gave you a sense of the distance. One is generally speaking, just the material in between. The maximum amount of material in between, or the material in between at any moment. But of course, we can never forget about electromagnetic fields or electromagnetic environment. So the thickness, the amount of electromagnetic fields between them can also be a measurement of the distance between them. So that as a light or as a photon travel from rather into the universe through millions, billions, even trillions of light years come to us, it experiences so much material, particle, and electromagnetic environments. All that torment, all that torture, many of them died. Purple ones, especially. And a green, blue, so on, yellow. And the red ones are rather resilient. They persevere, eventually got to Earth. And that's it. That doesn't mean their mother is leaving us. Huh? Their mother's still there. Okay, so since we mentioned distance, that's one measurement of space. Another measurement would be time. Space, really, when we measure, we are looking for things that is not changing. So where measure things do not change, or we measure the stability of our environment. Conversely, or correspondingly, the instability in our life, the change in our life, or unstoppable change in our life is time. So time is the changing element of our life, and a distance or length, a measurement of space is our stable part of it. How the time came about, I mean, we all know the history, but fortunately or unfortunately, our environment is somewhat periodic. The most obvious is day and night, and it's the concept of day, right? Over and over. Our ancestors thought they are periodic, they are repetition, and today, tomorrow, and yesterday they're all the same. But of course, later they realized they're different, and of course also 4 seasons and a year, and rather quickly people realized that years are different, and that's why we have a leap month. Yeah. But what if we really travel straight line in a Milky Way, and our environment changes every day? We go straight line, and then there's nothing to go back to, in any sense. Then the concept of time may may or may not be different. I imagine it would be different, but anyhow, nowadays we use the atomic clock, and then we found something rather steady, rather reliable, unlike sun or moon or rotation of the Earth. They are not they're not exactly periodic. But the oscillation of atoms, I'm pretty sure they're not mathematically periodic. Only our current technology can tell they are different, and their approximation to the mathematical repetition periodic is enough for our purposes at this moment in time. So that's why they become a standard of measurement of time. So I think this is let me make a conclusion that rather philosophical. Measurement of space is measurement of unchange or stability. Measurements of time, or the concept of time, is the measurement of change or instability. So space-time is basically stable and unstable. Change and stays the same. But of course, nothing stays the same. All right. Almost 17 minutes. Okay, next time I'll discuss the speed of light, and of course remember the light is a collective phenomena, and the photon is a point phenomena. Okay, see you tomorrow. Bye.